Okay, now let's look at on how to find cumulative distribution function for discrete random variable. So if cumulative distribution, we use capital F here, okay? So before this lowercase f, fx, like this that one is probability distribution. So capital Fx here referring to cumulative distribution, okay? So cumulative. Okay, look at this definition first. Okay, if x is a discrete random variable with probability distribution fx is, so the cumulative distribution fx is equal to probability of x less than equal to x, so will be equal to summation of ft where t less than equal to x for x from negative infinity to infinity. So if you look at here, probability of x equal to t is the value of probability distribution of x at t. Okay, so it is called the distribution function or the cumulative distribution of x. Okay, so cumulative distribution of x also is called as distribution function. Okay, if fx here lowercase fx here is probability distribution function. This one is distribution function. Okay, now look at theorem 5.2 here. So the values of cumulative distribution fx here of a discrete random variable x satisfying the following conditions. So these two, fx equal to 0 and fx here equal to 1, x approaches to negative infinity or to positive infinity. So this is actually properties of probability where values of probability must lie between 0 to 1. Okay, so remember cannot be more than 1 and cannot be negative. Okay, second one, if x1 less than x2, then cumulative of x1 also must be less or equal than cumulative of x2. Or if a less than b, so cumulative of a must be less than or equal to cumulative of b. So this indicates that probability of x greater than a but less than or equal to b will be given by cumulative of b minus cumulative of a. So it's okay if you confused by looking at this theorem. After this, we will look at example. Okay. Okay, now look at example 8 here. Okay, based on the probability distribution below, find the distribution function fx. So again, recall, distribution function also is called as the cumulative distribution. Okay. So find the distribution function fx of the random variable x. So given to us here, value of x ranging from 0 until 3 and its probability. Okay, so if x equal to 0, probability is 1 over 8, 1 3 over 8, 2 3 over 8 and 3 1 over 8. So if you total up this probability, the total must be equal to 1. Okay, now look at how to find the cumulative distribution or the distribution function. Okay, here I put fx, so f here to denote cumulative, okay? So fx equal to probability of x equal to x equal to summation. Summations means that you need to total up progressively, okay? So total later on must be equal to 1, okay? Summation of ft. T here referring to each value of x. Okay, now we start with 0. So f0 at f0 x less equal to 0, so the probability is 1 over 8. Okay, so up to x equal to 1 here or at t equal to 1 here. So f1 cumulative. Cumulative means that this probability x equal to 0 plus probability at x equal to 1. Okay, so if f1, so the value of x must be less or equal to 1. So what is less or equal to 1 is when x equal to 1 equal to 0. So cumulative means that you total up. Okay, total up at x equal to 0 and x equal to 1 when f equal to 1 here. Okay, so x equal to 1, the probability is 3 over 8 plus x equal to 0, the probability is 1 over 8. Up to F1, so total probability or the cumulative is 4 over 8. Okay, so if we simplify this one, if you want to put answer in simplest fraction also no problem. Okay, so here will be 1 over 2. Cumulative at F2, so it must be for probability of x less than equal to 2. So what is x less than equal to 2? Is at x equal to 2 and x equal to 1 and at x equal to 0. So what is the cumulative? Cumulative means you total up, okay, from 0 until 2, okay. So x equal to 2, the probability is 3 over 8, x1 just now 3 over 8, x equal to 0, 1 over 8. So if you total up, the cumulative is 7 over 8. Okay, so means that up to x equal to 2, the cumulative probability is 7 over 8. Okay, last one, at x equal to 3, cumulative at x equal to 3. So what is the cumulative? So the value of x must be less than equal to 3. So x less than equal to 3 will be at x equal to 3, at x equal to 2, at equal to 1, and x equal to 0. So that's why if you total up this one from 0 to 3, your answer will be equal to 1, which to denote the total probability. Okay, then how to write it in this form? Okay, so the cumulative distribution function fx. So you can write like this. Okay, why I put 0 first here and the last one here is 1? Because this one to indicate range of probability. Okay, so value probability is from 0 to 1. Okay, you put 0 first. So 0 is for x less than 0. Okay, why x less than 0? So if you look at our data, okay, so if x equal to 0, the probability is 1 over 8, right? So look at here. 1 over 8, x equal to less than equal to 0. So the probability will be equal to 1 over 8. If the probability less than 0, if value x less than 0, for example, if x equal to negative 1, then the probability is 0. Okay, so that is meant by this notation. Okay, then next, probability, the cumulative probability 1 over 8 here. So for x greater equal to 0 but less than 1. Okay, how to get this one? So if you look at here, 1 over 8 here, okay. So the probability of 1 over 8 is for x less equal to 0 but less than 1. Okay, so you look at between these two boundaries, okay, these two limits. Okay, why less than 1? Because up to 4 over 8 already when x equal to 1. Okay, next is the same. Okay, 4 over 8 here. So up to here is 4 over 8, right? This one. So 4 over 8 is for x greater equal to 1 but less than 2. Okay. So here 1, right? Up to here 1 over 8 plus 3 over 8 is 4 over 8. So 4 over 8 is for x greater equal to 1 but less than 2. Okay, 7 over 8. So 7 over 8 here. So why I put x greater equal to 2 but less than 3? So if you total up until here, 1 over 8 plus 3 over 8 plus 3 over 8 up to here is 7 over 8, right? So 7 over 8 is for probability when x greater equal to 2 but less than 3 here. Okay, because up to here probability already equal to 1. So lastly, 1 probability equal to 1 x for x greater equal to 3. Okay, so if value of x is 3, for example here, if x equal to 3, then probability equal to 1. Okay, so that's how we read the cumulative distribution. X equal to 3, then the probability is 1. So let's say if x equal to 4, then the probability also equal to 1. Okay, example here, if x less than 0, example less than 0, for example negative 2. So if x is negative 2, the probability will be 0. If x greater equal to 0 but less than 1, for example, what is the probability of x is 0.5. Okay, so 0.5 within this interval, right? So the probability is 1 over 8. So that's how we find the cumulative distribution function for discrete variable. Okay, now look at this example. Okay, I give you, let's say some question will give you cumulative distribution function, then find this probability. Okay, so previous example, we have example like this. Find, for example, find probability of x greater than 1 but less than 2 using the using the probability distribution, means that using this value. Okay, but you also can find this answer based on cumulative distribution. Okay, look at how to find it. Okay, what is probability of x more than 1 but less equal to 2? So what is more than 1 and less equal to 2? So the value will be x equal to 2, right? Okay, like this. So x greater than 1 is 2, right? So this is actually probability of x equal to 2. And x less than equal to 2 also will be this value only. So in this question, we want probability of x equal to 2. So if you look at from the table given here, if x equal to 2, the probability is 3 over 8. Okay, so this one if we use the probability. Okay, how we can use the cumulative distribution function to answer this question? So if you look at here, I put probability of x more than 1 but less equal to 2 is given by f2 minus f1. Okay, why f2 minus f1? Okay, so look at this guideline. Why f2 minus f1? I put here. Okay, you list how to get f2 and f1. Okay, let's say f1 cumulative at x equal to 1 will be at x equal to 0 plus x equal to 1. f2 will be x equal to 0 plus x equal to 1 plus x equal to 2. Okay, because up to x equal to 2. So from 0 until 2. Okay, question A, we want x equal to 2 only, right? So if you look at here, 0, 1, 0, 1, 2. Okay, we want f2 only. Okay, probability of f2 only. So how to get f2 only? So f0 minus f0 here will be equal to 0. Okay, means that if f0 just now is the value 1 over 8. Okay, so here 1 over 8 minus 1 over 8 is 0. f1, the probability is 3 over 8. So 3 over 8 minus 3 over 8, 0. So based on these two cumulative, what we have only f2. Okay, so that's why we can find this question by using f2 minus s1. F1. So again, this one f0 minus f0 here, then later on will be 0. f1 here minus f1 here also will be 0. Then later on we only have f2 only. So that's why x greater probability of x more than 1 less equal to 2 is given by f2 minus f1. Then you refer f2 minus f1. So where is f2? So look at here, x greater equal to 2. So this is f2. So 7 over 8 minus f1. Where is x equal to 1? So look at here, x greater equal to 1. So this is at f1. So 4 over 8. So 7 over 8 minus 4 over 8 is also equal to 3 over 8. Okay, which is also equivalent from this table. Okay, because some certain question, this table will not given to you. Okay, so it will give you directly value cumulative distribution. So based on this cumulative distribution, you need to answer question like this. Okay, now look at question B. So we want to find probability of x greater equal to 0 but less than equal to 2. Okay, so what is value of x between this interval? So here will be probability of x equal to 0, more equal to 0, and then plus probability of x equal to 1 plus probability of x equal to 2. Okay, until 2 only because less equal to 2. So in this question, we want probability of x equal to 0 plus x equal to 1 plus x equal to 2. So if based on probability distribution given here, so 1 over 8 plus 3 over 8 plus 3 over 8. So the answer will be 7 over 8. Okay, the answer is 7 over 8. Okay, but if you look at here, I put 6 over 8. Okay, here there is some mistake here. So if you look at here, question is x greater equal to 0 but less than equal to 2. Okay, so why my answer is 6 over 8 here? Okay, you notice here from here. So guideline solution for B. So there is a typing error here. Okay, so this is not 1. So this one will be 0. So if 0 here, you must add probability of x equal to 0. Okay, so if you want x equal to 0 plus x equal to 1 plus x equal to 2, so how to get the probability using the cumulative distribution? So if you look at here, okay, we want 0, 1 and 2, right? So if you list down f0, f1, f2, so in which cumulative you will get 0, x equal to 0, x equal to 1 and x equal to 2, okay? So in this case, this question is given by cumulative of f2 here, okay? So this one, the answer will be like this only, f2 only. Okay, so the answer will be 7 over 8 because we want value from 0 until 2. So that's why if based on if based on probability distribution here, 1 over 8 plus 3 over 8 plus 3 over 8, then up to x equal to 2 here, we will get 7 over 8. Okay. So if based on this guideline, what I did here, okay, if let's say I change this one equal to 1, okay, so this one will be from x equal to 1 to x equal to 2 only, okay. So how to get this probability using cumulative distribution given here? Okay, so you list down like this. Okay, you list from f0, f1 and f2. So we want 1 and 2 only, right? Okay, which cumulative at x equal to what? 2 minus which cumulative, okay? Okay, why f2 minus f0 just now? So f2 minus f0. Okay, why not f2 minus f1? Okay, if you look at the cumulative, okay, we want 1 and 2 only, right? Okay, if f2 minus f1, okay, f2 minus f1, f0 minus f0, f1 minus f1. Later on, we will get f2 only, so we cannot do f2 minus f1, okay? So if f1 minus f0, so 0, f0 minus f0, so later on you have f1 only, okay, so cannot. So if you want to find this question x greater equal to 1 but less equal to 2 is given by f2 minus f0, okay. So f2 minus f0, f0 minus f0, so later on will be 0. So what you have only f1 and f2, okay. So here we want 1 and 2 only. So if x equals to 1 here, so the answer will be f2 7 over 8 minus f0, which is, what is f0 just now? 1 over 8. Okay, so later on you will get 6 over 8. So please do some correction here. Okay, so you can do correction, either you want to change this one to 0, then you don't need to do correction in this part. But if you want to change this one, you want to maintain the original question where x greater equal to 0, then take note on this part, okay? So only you discard minus f0. So the answer only 7 over 8. Okay, question C, we want property of x equal to 2. So if x equal to 2 from the probability distribution given is 3 over 8, right? Okay, if this table is not given, but you only have cumulative, how to get x equal to 2 only? Okay, so y f2 minus f1, again you list like this, okay? Okay, look at here. Y f2 minus f1, f0 minus f0 later on will be 0, f1 minus f1 will be 0, and then later on we only have f2 left here, okay? So that's why if property of x equal to 2 is given by f2 minus f1, f2 minus f1. So f2, look at f2. X greater equal to 2 is 7 over 8. So minus f1, x greater equal to 1, which is 4 over 8. So 7 over 8 minus 4 over 8 is 3 over 8. Okay, last one here. We want probability of x equal to 1. Okay, if based on cumulative, y f1 minus f0. Okay, so again, you list like this. Okay, f1 minus f0. We want x1 only. Okay. So f0 minus f0 will be 0, and then later on only left with f1 only, okay? So why cannot f2 minus f1? So if f2 minus f1, f0 minus f0 0, f1 minus f1 0, so later on only f2, but we want x equal to 1 only, okay? So that's why here f1 minus f0. So f1 when x greater equal to 1, so 4 over 8, so here 4 over 8, minus when x equal to 0, so this is x greater equal to 0 means here, so the probability is 1 over 8. So 4 over 8 minus 1 over 8 is 3 over 8. So if you look at from probability distribution given, so if x equal to 1, the probability is 3 over 8. Okay. So that's how we use cumulative distribution in order to find the probability. Okay, now look at this example. Okay, find the cumulative distribution function fm of the random variable m below. Hence, construct the cumulative distribution table. Okay. So previous example, okay, we did not put the cumulative in table. Okay. So this example, we will put the cumulative distribution in terms of table. So start with at x equal to 0. So cumulative capital F, F0. So F0 you need to start at x equal to 0. So F0. So F0 the probability is 3 over 28. Okay, then x equal to 1. So cumulative up to x equal to 1 will be F0 plus F1. Okay. Cumulative, so means you total up accordingly. So F0 just now, sorry, this one is F1, okay, not F10, F1. So F0, 3 over 28, plus F1, 15 over 28. So up to F1, the cumulative is 18 over 28. Okay, then F2, up to F2. So F2 will be, you start cumulative start from F0 plus F1 plus F2. So we know that up to F1, F0 plus F1 is 18 over 28, right? So you just use from F1 to save time. So plus F2. F2 is 5 over 15. Okay. So again, this one is from F1. Okay. So to save time, no need to write again 3 over 28 plus 15 over 28. Okay. So you just use this value. So the answer here will be equal to 1. Okay. Because total probability must be equal to 1. Okay, next question asks us to construct the cumulative distribution table. Okay, so how to construct the cumulative? So you just add here another row. Okay, So cumulative you put Fm, capital Fm. Okay. So what is the cumulative? At x equal to 0, the cumulative is 3 over 28. Up to F1, the cumulative is 18 over 28. And last one, up to x2, total probability is 1. Okay. So that's how we construct the cumulative distribution table. Okay, if you want to put in terms of this interval, okay, so how to put in terms of this interval? Cumulative distribution Fm, so start with 0 because value probability ranging from 0 to 1. Okay, so here you put 0. So 0, probability 0 is for m less than 0. Okay, why less than 0? Because 3 over 28 if m equal to 0. So if less than 0, for example, if value m is negative 1 or negative 2, then the probability will be 0. Okay, so that is meant by m less than 0. Okay, if m equal to 0, okay, the probability is 3 over 28. So here is the probability. So 3 over 28 is for m, okay, greater equal to 0. So m greater equal to 0 here, but less than 1. Okay, so up to here, but less than 1. Okay, next, up to x equal to 1, the probability is 18 over 28. So 18 over 28 is for m greater equal to 1. Okay, greater equal to 1, but less than 2. Okay, last one, if probability equal to 1, so probability equal to 1, so this is for m greater and equal to 2, okay? So if m equal to 2, then the probability is 1. Greater equal to 2, greater equal to 2, for example, m equal to 4. So if m equal to 4, the probability also equal to 1. Okay, now let's look at on how to find the expected value or value mean of a discrete random variable. Okay, the expected value and also the variance. Okay, let x be a discrete random variable and fx is the value of its probability distribution at x. So the expected value or the mean value and variance is given by, so how we calculate the expected value or mean? So E represent expected, okay? So expected value of x is given by summation of x multiplied by fx, okay? So x multiplied by its probability. So variance of x is given by expected of x squared minus expected of x. So expected of x here is referring to the ex here. Okay, so you square the value. Okay, if x is a discrete random variable and fx is the value of its distribution function at x, the expected value of the random variable gx is given by, so let's say if you have something like this, the expected of gx, okay, so this one is given by summation of gx then multiplied by its probability, okay. Okay, now look at this example. Okay, given the following probability distribution function for a discrete random variable x. Okay, calculate the expectation and variance of random variable x. Okay, expectation means that value mean expectation of x. Okay, how we calculate ex? So ex equal to summation of x multiplied by fx. So again, fx is the probability for that value of x. Okay. So look at this example. So how to find the expected value or the mean? So expected of x equal to summation of x multiplied by fx. So summation means that later on you total up the product of x multiplied by its probability. So here x start from 0 until 6. Okay, look at here. X multiplied by fx. So when x equal to 0, the probability is 0.1. Okay, so x multiplied by fx. So here 0 multiplied by 0.1. Okay, summation plus, so if x equal to 1, the probability is 0.15. So 1 multiplied by 0.15. So do the same thing until last value of x. So last one, 6 multiplied by 0.04. So if you total up this one, you will get 2.64. Okay, so the expected value for this problem is 2.64. So again, expected value and value variance can be more than 1. Okay, because this is not probability. This is about mean and variance. But recall from chapter 2, value variance cannot be negative. Okay. Okay, now look at how to find the variance of x. So just now, variance of x equivalent to expected of x square minus expected of x square. So again, here is the mean, value mean square. So how to calculate ex square here? So if ex is given by x multiplied by fx, so if ex square got square here will be x square multiplied by fx. Okay, so example here. So ex square, so the first value of x equal to 0. So 0 square multiplied by its probability 0.1 plus 1 square, okay, because square here, 1 square multiplied by probability 0.15 up to last value of x, which is x equal to 6 here. So 6 square multiplied by 0.04. So if you total up this one, ex square, you will get 9.34. Then, how to get the variance? Substitute value of ex square and ex. Okay, so variance of x equal to expected of x square, so which is 9.34 minus value mean square. So ex this now is value mean. So minus 2.64 square. Okay, so variance of x here we will get 2.37. So be careful with these two values. Okay, these two values is different. Okay, now let's look at this example. Okay, given the following probability distribution function for a discrete random variable x, so calculate expected of x and variance of x. So expected of x is given by summation of x multiplied by fx. Okay. So expected of x equal to, so first value of x is 2, fx is 0.22 plus 3 multiplied by its probability 0.27 plus 4 multiplied by 0.25 plus 5 multiplied by 0.26. So here expected of x, we will get 3.55. Okay, variance of x, so variance of x equal to expected of x square minus expected of x and then square. So we need to find ex square here first. So ex square is summation of x square multiplied by fx. So first value of x is 2 square multiplied by probability 0.22 and then plus 3 square multiplied by 0.27 and then 4 square multiplied by 0.25 and last one 5 square multiplied by 0.26. So ex square is equivalent to 15.81. So what is variance of x? Okay, so substitute into formula variance of x. So variance of x equal to expected of x square, so which is 13.81 minus mean square. So mean square just now is 3.55. So 3.55 square. So here the variance is equivalent to 1.2075. Okay, so remember variance cannot be negative. Okay, that's how we find expected value of x for discrete variable. Expected value is mean and the variance. Okay, later on, example 14, you do it on your own. So the answer is here, okay? So expected of y is 1, expected of y square is 1.4, and expected of y cube is 2.2. So how to find expected of y cube? So if expected of y square is y square multiplied by fy, so if y cube will be summation of y cube multiplied by fy, okay? Okay, now let's look at next, which is rules of expectation and rules for variance. Okay, rules of expectation, expected of x. Okay, for example, number one, if you have expected of c, so where c is a constant, so the value will be equal to value c itself. Okay, for example, expected of 3 will be equal to 3. Okay, number two, expected of cy. So this one equal to, so since c is constant, you can take it out. So c multiplied by expected of y. Okay, later on we see with examples. So just look at the rules first. Okay, expected of cy plus d will be equal to c multiplied by expected of y plus d, where c and d is a constant. So if constant, you can take it out. Okay, number 4, expected of CGY is equal to C multiplied by expected of GY, where GY is a function of a random variable Y. So this also we will look at example in detail. Okay, last one, expected of G1Y plus G2Y up to G and Y means that you have more than one function here. So this one will be equal to expected of G1Y multiplied by expected of G2Y plus until expected of G and Y. Okay, now look at rules of variance. Okay, if variance of C, where C just now is constant, so variance constant equal to 0. Okay, for example, variance of 5, so variance of 5 will be equal to 0. Okay, variance CY, again C is a constant, so variance of CY equivalent to C square. So remember here, if variance C here, you must square. Okay, so C square multiplied by variance of Y. Okay, variance of y plus c will be equivalent to variance of y only. Okay, because, okay, look at here. Variance of y plus c can be written as variance of y plus variance of c. Okay, so you separate these two. Okay, variance of y is given by variance of y. Variance of c, where is constant just now, c is constant. So variance of constant is 0. So variance of y plus 0 will be variance of y only. Okay, now let's look at this example. Okay, from a study, it is found that the mean daily temperature in June in Kuching is 27.5 degrees Celsius and the variance is 6.2 degrees Celsius. Okay, find the mean and variance of the temperature in Fahrenheit F if F equal to 1.8x plus 32. Okay. Okay, where x is the unit temperature in Celsius. Okay, now if find the expected of F. Okay, so we know that function that we have here is 1.8 plus 32. So given that the expected value mean is 27.5 and its variance is 6.2. Okay, how to find expected of f? Okay, we want to find expected of this function. Okay, you write like this. Expected of f equal to, so you find expected all these numbers. Okay, so expected of in bracket 1.8 x plus 32. So here you apply the rules of expectation here, okay? So 1.8 is constant, right? So you take it out constant. So will be 1.8 multiplied by expected of x plus 32. So 32 also is constant. So you expand this part, expected of 32. Okay, 1.8 multiplied by expected of x. So we know that expected of x is 27.5. So substitute the value. So 1.8 multiplied by 27.5 plus expected of 32 also equivalent to 32. Okay, which is the first rule of expectation here. Expected of constant is constant itself. So the expected of f is 81.5. Okay, how about variance of f? Okay, so variance of f. So variance 1.8x plus 32. So again 1.8 is constant. So take it out constant. So if you look at rules of variance, if constant here, so you need to square the constant. Okay. So 1.8 square multiplied by variance of x and then plus expand this one. So plus variance 32. So replace value variance of x which is given as 6.2. So 1.8 square multiplied by 6.2 plus 0. Okay, why 0? Because from rules of variance it says that variance of constant equal to 0. Okay, so plus 0. So variance of x we will get 20.9. Okay, now let's look at this example. Okay, given the probability distribution function for K, where K denotes the number of cars sold by a salesman weekly. Okay, so K we have starting from 0 until 4 and with its respective probabilities here. Okay, suppose that the salesman will get 250 as a fixed weekly income and 500 for each of the cars sold. Okay, so this is the variables. So the weekly income for the salesman will be J will be the income. So the income equal to 500k plus 250. Okay, so 250 fixed. So that's why this one is the constant. And for each car sold, you will get 500 ringgit. So that's why here 500k, 500 multiplied by k, where k denotes the number of cars sold. Okay, now you have this function. Okay, calculate the expected income J. Okay, so here, how to write your answer? So we know that J equal to 500k plus 250. So expected of J equal to expected of 500k plus 250. So if we expand this one, so 500 is a constant, so take out constant 500 multiply by expected of k and then plus expected of 250. Okay, now we don't have value expected of k, right? So we need to find expected of k first. So expected of k equivalent to summation of k multiplied by fk. The summation of k multiplied by its probability, okay, fk. So here when k equal to 0, probability 0.05 plus x equal to 1, probability 0.15 plus k equal to 2, probability 0.35 plus k equal to 3, probability 0.25, and last one if k equal to 4, probability is 0.2. So this one expected of k equal to 2.4. Okay, so once we get value expected of k, then you substitute into the income here. Okay, so the weekly income, so 500 multiplied by expected of K, so 500 multiplied by expected of K, 2.4 plus expected of 250 is 250. Okay, so expected of constant is constant. So here the income, the weekly income will be 1450. Okay, question B, variance for J. So variance for J, we need to find EK square first. Okay, so I just copy this one. So variance for J, find EK square first. So here also square. K square multiplied by Fk. So here will be each value of K here you need to square. So EK square will be equal to 7. Okay, so variance for J. So variance for J equal to variance. So J just now equal to 500K plus 250. So take out the constant. So 500. So if constant, don't forget to square. Okay. 500 square multiplied by expected of K. And then plus, sorry, not expected, variance. Now we find variance. Okay, variance of K plus variance of 250. So here 500 square is 250,000. So variance of K, so we need to find variance of K first. Okay, so here variance of K will be variance of K equal to EK square 7 minus expected of K square 2.4 square. So variance of K equal to 7 minus 2.4 square is 1.24. Okay, once we get variance of K, then substitute here 1.24. Okay, plus variance of constant is 0. Okay, refer rules of variance just now. So this one variance will be equal to 310,000. Now let's look at this last example. So this example, a formula or an equation is given. Okay, the discrete and the variable y has the probability distribution function given as 3y plus 1 equal divided by 22 for y start from 0, 1, 2 and 3. Okay, find expected of y, expected of y square, expected of 3y minus 2 and expected of 2y square plus 4y minus 3. Okay, so in this type of question, to issue, you construct a table in order to find probability for each value of y. Okay, so easy for you to refer. So let's say I put here like this. So here is value y. So this one will be the probability. Probability of y equal to y. Okay, y 0, 1, 2 and 3. Okay, if y equal to 0, what is the probability? So it means that you substitute y equal to 0 in this equation. So 3 times 0, 0 plus 1. So divided by 22 is 1 over 22. So if y equal to 1, so will be 3 times 1, 3 plus 1, 4. So 4 over 22. So if y equal to 2, 2 times 3, 6. 6 plus 1, 7. 7 over 22. And last one will be 3 times 3, 9. 9 plus 1, 10. 10 over 22. So if we total up, total probability must be equal to 1. Okay, so 10 plus 7, 17, 21, 22. Okay, 22 over 22 equivalent to 1. Okay, find expected of y. So again, expected of y equal to summation of y multiplied by fy. Okay, probability of y equal to y also can be written as fy. Okay, so if you write fy here, also means that referring to the probability. So this one equal to so y0 times probability 1 over 22 plus 1 times 4 over 22 plus 2 times 7 over 22 and last one 3 times 10 over 22. So this one will be equivalent to 2.18. Okay, expected of y square. So you just square this part, y square. So I just copy here. So square. So here y square, okay. So I just square here. So expected of y square, we should get 5.56, okay. Simple calculation only here. Okay, next question C, expected of 3y minus 2. So here you take out the constant. So 3 expected of 3y minus 2 can be written as 3 multiplied by expected of y minus expected of 2. So 3 multiplied by expected of y just now 2.18 and then minus expected of 2 is 2. Expected of constant is constant. So 3 multiplied by 2.18 is equivalent to 6.54 minus 2. So 6.54 minus 2 is 4.54. Okay, last one here. Expected of 2y square plus 4y minus 3. So expected of 2y square plus 4y minus 3 can be written as this one is 2y square. So take out the constant. So 2 multiplied by expected of y square. Expected of y square. Okay, and then plus take out constant for 4 multiplied by expected of y and then minus expected of 3. So substitute the value 2 times expected of y square just now is 5.56 and then plus 4 multiplied by expected of y which is 2.18 and minus expected of 3. So this one if you calculate expected of 3 is 3, okay. So substitute expected of 3 equal to 3. So this one the answer will be, if you calculate you will get 16.84. Okay, so that's how we find the cumulative distribution, mean or expected value and variance for discrete random variable. So later on we will look at for continuous random variable, okay.